Hello, dear students. Today we are looking at slope-intercept form notes now, and so your page will look like this. Notice we have a couple of important things that we need to focus on. The title of your page should be saying slope-intercept form, and you should also add that, please, to your table of contents. So do that now. Pause the video if you need to. As well, the y equals mx plus b part, this part right here, you are essentially cutting out a sheet of, or you're cutting out that rectangle, you're folding it in half hot dog style, and then wherever you see these dotted lines, you are cutting them just to the fold. And that way they will flap up. After you've done that, please tape that whole piece of paper in the top section of your notebook, sort of the top half of it. So that way you have these little flappy doos and that sort of thing. Notice that there is a little bit of tape right here, keeping that equal sign just taped down, so you can do that if you'd like. As well, I have then those two other graphs and the equations that go along with them taped below it. So get your notebook all set and ready to go. If you need to, go grab yourself some scissors, go grab yourself some tape. Get this taped in, do it quickly, and pause the video as you do that. I am going to move on because I clearly already did that. So here we go. To start out with, we have our equation y equals mx plus b. So that is our slope-intercept form of a linear equation. So it is a form that shows us instantly the slope and instantly the y-intercept, which allows us to graph this super easily. Essentially, we would always have a starting point. So we'd always have a point along the y-axis that we could plot a point on, and then from there we can use that slope to sort of figure out where that line is going to go from there. So this slope-intercept form is super helpful for graphing, so being able to get an equation into this format is really nice. So let's get a little bit of information in there. Each of these flappy doos, you'll be able to flap them up, and I want you to put a little bit of information there. We've talked about independent versus dependent variable. We've talked about specifically that idea with our bridge building stuff. And so we talked about independent versus dependent. When it comes to the y, or when it comes to y, that is essentially our dependent variable. So we're going to add that information in here. So I'd like you to write dependent variable. Okay, so it is also considered the output. So whatever you put into this equation, you'll get out something. Oh my goodness, that's horrible handwriting. Let me erase this and restart. So we have the dependent, that's not an E, dependent variable. We can call that the output. There we go. Then from there, there's more information that we're going to know. We always have the equal sign. It's always going to be there. So we have our output, and then underneath the M, we've talked about this multiple times. We've called this the slope. This is our rise over the run. It's the steepness or shallowness of the line. We've done a lot of discussion on this. Next, as you can tell, we're moving down the line. I'm going to now talk about the X. That X, I'd like you to write underneath here. This is, if we had the Y as the output, the X is our input. So our X is our input. This is the independent variable. Essentially, anything that I put on the x-axis, if I put a 1 on the x-axis, I can put this into this equation and do a little bit of mathematics, and I'll pop out my y-intercept, or the corresponding y value, not y-intercept, sorry, the corresponding y value that goes in there. So I'll get an input and an output. So essentially I'm putting in something to this like equation or this machine, And when it comes out, it'll be modified hopefully some way, and I'll be able to plot that point. Next, moving on down the line, we have our B. Actually, not. Wait, stop. We're not moving on down there. We're going to move on to actually our plus sign that we have here. This plus can be either an addition sign or a subtraction sign. So it could be plus or minus. So don't get super comfortable seeing y equals maybe 2x plus 4. We could also, or plus 4, we could also see potentially y equals 3x minus 1. Essentially, whenever you see a subtraction sign, we could rewrite that so it is completely in slope-intercept form with an addition sign. We could rewrite that as y equals 3x plus a negative 1. So we can rewrite these equations, but just know that that plus sign could sometimes look like a subtraction sign. So add plus or minus. Then underneath the b, we've talked about this before, the b is our y-intercept. This is our starting point. So add those under each and every one of those flappies. If you don't have that written down, you haven't done the notes page for this, and this page will be completely useless to you. So please write those little bits underneath each of those things, so that way if you're ever in a test situation or quiz situation where you can use your MISN, you can flap it up and you can say, oh right, m equals slope and blah blah blah, and go on from there. So now you should have a completed notes taken for y equals mx plus b, and we will move on from there. So now we're actually going to create a few graphs. We have y equals 4x minus 3. So we're going to use this information to graph this equation on here. What I see here is I have my output, and I have my input, I have a slope, and I have a y-intercept. And this time I'm boxing that whole y-intercept because it says minus 3, and as we can recall, just before I said we could technically rewrite this as saying 4 is equal, or y equals 4x plus a negative 3. We can always write a subtraction as a plus a negative. So do that, so that way you're like, okay, my y-intercept is at 0, negative 3. It's at that one point. So 1, 2, 3, I'm going to mark 0, negative 3 on my graph. After I do that, I'm going to use my slope. This 4, for me to really understand that this is a slope, it's technically rise over run, but I don't see this written as a fraction. Any number can be written as a fraction if we put it over 1. So 4 over 1 is the same thing as 4. We know 4 divided by 1 is 4. So now from there I can actually graph this completely. So from this starting point, I am going to go up 4 numbers, and I'm going to go to the right 1 number. So I'm essentially working backwards to what we've been doing for the last couple of days. So I'm going to go up 4 and to the right 1. And then I can slowly start connecting these dots and making this nice steep line on my graph. And I'm done. I have just graphed the line y is equal to 4x minus 3. Done. We're going to do one more example right here. We have y is equal to, we have y is equal to 3 over 5x minus 6. Again, I'm going to write this as plus a negative 6, so 3 over 5x plus a negative 6. Excuse my awesome handwriting with this stylus. It's not the best. And so I'm going to go down 6 because I'm going to use my y-intercept as my starting point, and I'm going to make a line, or make a dot. And as I make that dot, I have a 0, negative 6 for that starting point. After I've done that, I'm going to use my slope. It's already written in fraction form. My rise is 3, my run is 5. So I'm going to go up 3, 1, 2, 3, and to the right 5. 1, 2, 3, 4, 5. And I'm slowly going to make that line. So this line, we can write this as y is equal to 3 over 5x minus 6, or plus a negative 6. And I'm done. That is how we use slope-intercept form to graph equations. First going to use my y-intercept, then I'm going to use my slope. Make sure you take good notes. Please put these notes in your notebook, and after you've done that, start working on investigation 2.3. Thank you for listening.